Next, we want to look at actually reading and interpreting the binomial distribution, which is just a graph that consists of a series of points. Each point has an x and a y coordinate, where the x coordinate is telling us the number of successes, and the y coordinate is telling us the probability of getting that number of successes. So for instance, in this example, we're talking about flipping a fair coin 10 times and then counting the number of tails. The dot that I'm going to highlight here represents getting tails 5 times, and the distribution is telling us that the probability of that happening out of 10 flips is 0.2461. Using this then, we can answer some questions about probability. In part A, we want the probability that t equals 4, so we get tails 4 times. We would find where x equals 4 and find that corresponding probability, which in this case is 0.2051. In part B, we want the probability of getting tails 9 times. So we would find where x is equal to 9, and that probability is 0.0098. Those were examples of two very easy cases where literally we just find that point and read the probability. But we can also look at more complicated probability statements. For instance, in part C, the probability that t is less than or equal to 2, meaning what's the likelihood that we get tails 2 times or fewer. This is the same thing as the probability of getting tails 0 times plus the probability of getting tails 1 time plus the probability of getting tails 2 times. Since those are mutually exclusive events, we can find those individual probabilities and add them together. Looking at the graph up above, we can see that the probability of getting tails 0 times is 0.001, plus getting tails 1 time is 0.0098, plus getting it 2 times is 0.0439, for a total probability of 0.0547. We do need to be careful with inequality statements, because if we look at part D, we have the probability that t is greater than 8. That means getting tails more than 8 times. Another way to say that would be tails is greater than or equal to 9. Since that would be all values that are larger than 8. So that would be the probability of getting tails 9 times plus the probability of getting tails 10 times, which would be 0.0098 plus 0.001, or 0.0108. Since we had that strict inequality, we don't include 8 as a success, only values larger than 8. In part E, the probability that t is between 4 and 6, including both 4 and 6. So that's the probability that t is equal to 4, plus the probability that t is equal to 5, plus the probability that t is equal to 6. So we would add up all three of those probabilities to get 0.6563. And then in part F, we have the probability that t is between 2 and 5. But in this case, again, with strict inequalities. So this would be the same thing as saying 3 is less than or equal to t is less than or equal to 4. So now we're only including values that are larger than 2 and values that are less than 5. So we would find the probability that t equals 3 plus the probability that t equals 4, and add those together to get 0.3223.